This is for class 12. Today I am going to tell you a conceptual fact. It is given in your book. So here you see that your resistivity, here you see this resistivity, it depends on temperature. The formula is rho naught 1 plus alpha T minus T naught, where alpha is the temperature coefficient of resistivity. So your resistivity of a material, it depends on the temperature. That means now here two facts comes. One is metal and other is non-metal. Non-metal or semiconductors. There are two things here. Now let us see how resistivity increases with the rise in temperature. Let us see how in metals resistivity increases with rising temperature, whereas in non-metals resistivity decreases with the increase in temperature. How? The point is how. Now we know that the relation between current density and electric field. The current density is sigma times E, that is, this is the conductivity of the material. This is the conductivity of the material. And again, here this current density is related to electric field. M is the number of electrons per unit volume. E is the charge of the electron. Tau is the relaxation time. M is the mass of the electron. So if you equate these two, your conductivity is M E square tau by M, and your resistivity is inverse of conductivity, so M by N E square tau. Now here what happens that when the temperature rises, that means if the velocity of the electron increases, if the average velocity of the electron increases, then the collision time decreases, that is tau decreases. Here see tau decreases. With rising temperature, that means your average velocity of the electron increases. As the average velocity of the electron increases, the collision time decreases. So when the collision time decreases, your resistivity increases. So in metals, what happens, that is the relaxation time. That is the collision time. It decreases. Since the collision time decreases, your resistivity increases, and the collision time decreases. Why? Because of the rising temperature, the average velocity of the electron increases. That means the frequency of the collision increases. That is the frequency of the collision increases. So here we find that the resistivity increases, and at the same time the number of electrons, does not depend on temperature. So in metals, with the rise in temperature, your average velocity of the electron increases, so your collision time decreases, and as this collision time decreases, your resistivity increases. But in case of non-metals, what happens, that is with rising temperature, non-metals or semiconductors, with rising temperature, the number of electrons increases. But no doubt the relaxation time decreases. But in comparison to these two, there is more number of electrons. With rising temperature, there is more number of electrons. So it can easily compensate this effect. So because with rising temperature, the number of electrons increases, no doubt the relaxation time decreases. Yet this number of electrons, that is in large number, which compensates this effect. And since the number of electrons increases, your resistivity of the non-metal decreases. This is an important fact. Why? With rising temperature, the resistivity of the metal increases, and with rise in temperature, why? Resistivity of non-metal or semiconductor decreases. Thank you.